Now I am going to explain about spring test. To determine the stiffness of the spring and modulus of rigidity of the spring wire. See, this is the spring coil. This is closed coil. This is open coil spring. Okay. What are the materials required for in this experiment? First one is spring testing machine. This is a spring testing machine, and this is a specimen spring and vernier caliper as well as micrometer also using. Vernier caliper using purpose for to find out measure dimension for the given spring. Okay, so this is major diameter capital D, diameter of the coil. So by using with the help of vernier caliper, we have to measure spring coil diameter. Okay, and this one is spring wire. In the spring wire also you should find out. Okay, that is small d. It's denoted by small d. So capital D is represent the diameter of coil, and small d is represent that diameter of the wire. This is the spring testing machine. So now we are going to conduct spring testing tensile test. So now we are going to fix the component in between that two hooks. This is a deflection scale. In this setup is using purpose for to apply tensile force. Okay, to apply the tensile force. See, this is indicator. Okay, so in this spring test indicate how much load apply on the particular specimen. The diameter of the spring coil. So this is the diameter of the spring coil. How much? 38.5 5 mm, and diameter of spring wire is 4 mm, and number of turns in spring is 25. See, the 25, and mean coil diameter is equal to capital D minus small d divided by 2 is equal to 17.25 mm. Okay, for in this particular specimen spring, and this is a tabulation. This is a tabulation. 5 values will take now. Going to take then the load in kgf. So it is represented W, and deflection in mm. It represents delta, and the rigidity of modulus in terms of Newton per mm square. The symbol is C, and stiffness in Newton per mm. So now I am going to conduct the experiment. So now I am going to fix in this helical spring. This is called closed helical spring. Now I am going to fix in this device like this. Now I am going to rotate in this elevating screw. In this, simply it will be lift up. What happened? The tensile force is acting on in this spring. Okay. See, first you have to set 0 value. You can fix the 0 value. Now we can mark in this pointer. In this pointer is shown. I am going to mark on this in this scale like this. Okay, so this is called null position. See, this is the null position, and no load position. No load position you should mark in this deflection as well as load also. Now I am going to gradually increase the load. How much I have to increase the load means gradually 10, 15, 20, 25, 30, whatever your wish, you have to apply the load. But so now I am going to apply the load. The ranges are already mentioned in this table. 10, 15, 20, 25, 30 with respect to load, how much deflection will happen. Okay, then 15, 20 up to 30. I am up to 30 you should take. So now I am going to apply the load. See here, the no load apply. The first load is 10. So now I have to increase the load. See, ten kg. See, 10 kg. you should note in this value already zero value already here marked. After apply the load, how much load 10 kg apply on in this helical spring, the tensile force is acting on in this spring. What is the deflection means? You should note here, you should mark on it, you should observe it. The deflection value is 30 with respect to 10 kg 30. Okay, so first value noted. So the deflection value is 30 mm. Again I have to increase 15. Okay, next to 5 kg, increase 5 kg. Okay, so 15 second load applied 15 kg. Then again you note down the value. So the second value definitely above 30. So 30 here, the second value deflection how much? 41. Next I have to increase 20, third value. C20, again mark here. Next value, deflection value is 55. Okay, 55. So next I have to increase the load up to 25. See, 25 kg load apply on in this spring. Again you note down in this value. The value is 69. Okay, 69. After that you have to increase the final load 30. See, the final value with respect to 30 kg, how much deflection occurred? Exactly 83 mm. Okay, so now we complete the experiment. So now completed all the readings with respect to all the load, 5 loads, 10, 15, 30, sorry, 10, 15, 20, 25, 30, 5 values are applied, and then deflection values are noted. Okay, after that you release the load. Okay, afterwards you release the load. Okay, then you have to remove it. Then after release of load, then you have to remove the specimen from the machine. Okay, so now the experiment completed, then we can go to calculation. Suppose I need to conduct a compression test, means should remove these 2 hooks, then we have to fix over there, and then you should rotate in this particular elevator screw. It will move downward direction, the spring will be come to compress. Then again you note down the same deflection value, you substitute in table, then do the calculation. So now I am going to do calculation. This is stiffness in terms of Newton per mm. The formula is K is equal to W by delta. W means load, delta means deflection. So the first reading is 98.1. See in this table 98.1 and divided by 30. Okay, the value is 3.27. So substitute in this table. Okay, so 3.27 for reading 1. Then second reading 147.15 divided by 41, because in this load is converted into Newton. So Newton means 9.81, you should multiply 2 kg. Okay, the second value is 147.15 divided by 41, so 3.58, and third value is 196.2 by 55 is equal 3.56 Newton per mm, and fourth value is 3.55 and fifth value is 3.94. All the values are here filled in this observation table. Okay, after complete the experiment, after the calculation, the values, the answer values are should fill in this table. Okay, so stiffness values are found. Next one, rigidity in Newton per mm square. So modulus of rigidity C is equal to 8WD suffix m cube n divided by delta d power 4. D means diameter of wire, capital D, dm means mean diameter of the coil, W means load, delta means deflection, already know very well. So first reading is, so 8 into the first value load is 10, and already found dm value, the 17.25 whole power whole the cube into n means number of turns, how many number of turns in available spring, the 25 divided by 30 into 4 by 4. The value is 136.70 Newton per mm square. Then second value, the second load, and what is the deflection already got, you should substitute in this formula. You got 2005.05. Then third value is 1458.22, and fourth value 1452.941, and fifth value is 1449.44. After that, all the values are calculated, then filled in this observation table. Okay, rigidity modulus of rigidity in terms of Newton per mm square, all the values should filled in this table. Okay, this is the final result for modulus of rigidity for the particular spring conduct by tensile strength, and this is the stiffness. Okay, this is stiffness final answer. After complete the experiment, the graph should plot like this. The x-axis represents the load. Okay, here 5 loads are here mentioned. See, this is 10. Okay, this is 15, this is 20, and this value is 25 and 30 load. Okay, with respect to load, what are the deflection observed? All the deflection value should plot in this graph. So the graph will come like this. Okay, this is the final answer. Thank you.